Day 13 of 60. Today we are setting up Zipkin for distributed tracing. If you have ever stared at logs from 20 different services trying to figure out why a single request took 8 seconds, you already know why this matters. Zipkin stitches those scattered logs into a single trace that shows you exactly where time was spent. Let me walk you through the architecture, deployment, and the production details that documentation tends to skip. Zipkin has 4 core components. First, the collector. It receives spans from your services over HTTP or Kafka. In high-throughput environments I use Kafka as a buffer between services and the collector, which prevents span loss during traffic spikes. Second, the storage backend. Zipkin supports Elasticsearch, Cassandra, and MySQL. Elasticsearch is my default for new deployments because its full-text search makes filtering by span tags fast during incidents. Cassandra works well if your team already operates it. MySQL is fine for development but falls over around 10,000 spans per second in production. Third, the query service exposes a REST API for trace retrieval. Fourth, the web UI renders waterfall diagrams and a dependency graph. That dependency graph alone has saved me hours during incident response by showing unexpected service-to-service calls that were invisible in logs. Let me show you the Docker Compose deployment. I am running Zipkin with Elasticsearch storage. The Zipkin container sets storage_type to Elasticsearch and points ES_hosts at the Elasticsearch container. I set the collector sample rate to 1.0 for development, but we will change that for production. The Elasticsearch container runs in single-node mode with security disabled for local development. I add a health check so Zipkin waits for Elasticsearch to be ready before starting. The whole stack comes up with Docker Compose up and Zipkin is accessible on port 9411. In production, you would add resource limits, persistent volumes for Elasticsearch data, and TLS between the containers. Now for instrumentation. Zipkin uses B3 propagation headers to carry trace context across service boundaries. The headers are X, B3, trace ID, X, B3, span ID, X, B3, parent span ID, and X, B3, sampled. Every HTTP call between services must forward these 4 headers or the trace breaks. With Spring Boot, the Brave library handles this automatically. You add micrometer tracing bridge Brave and Zipkin reporter Brave to your build file, set management.tracing.sampling.probability and management.zipkin.tracing.endpoint in your application YAML, and Brave intercepts every incoming request, creates a span, and attaches B3 headers to all outgoing REST template and web client calls. For custom spans around business logic, you inject the tracer bean and create spans manually with tags like payment.amount, customer.tier, and error status. Sampling is the most important production decision. Sampling at 100% means every request generates spans. At 50,000 requests per minute, that is a huge volume of data flowing to your collector. It adds latency to every request and can overwhelm Elasticsearch. I start at 10% sampling globally and override to 100% for specific critical endpoints like payment processing or authentication. Span tags versus annotations. Annotations mark moments in time within a span, like client send and server receive. Tags are key-value pairs for searchable metadata. In practice, I use tags far more than annotations. Good tagging means you can search for http.status_code equals 500 or customer.tier equals enterprise and find exactly the traces you need during an outage. Zipkin versus Jaeger. Both implement distributed tracing and both work well. Jaeger was built at Uber and has native adaptive sampling, which automatically adjusts sample rates per endpoint based on traffic volume. Zipkin has a larger ecosystem of client libraries through the Brave project, covering Java, Go, Python, Ruby, and JavaScript. Zipkin is operationally simpler, just a single binary with storage. Jaeger has more moving parts, but the Jaeger operator on Kubernetes simplifies deployment. My rule of thumb: Zipkin for Java and Spring Boot heavy teams, Jaeger for Kubernetes native organizations that want adaptive sampling. For brand new projects, I instrument with the OpenTelemetry SDK and use a Zipkin exporter. That gives you all the benefits of the Zipkin backend and UI while keeping a clean migration path to any other backend later. Quick summary. Zipkin has 4 components: collector, storage, query, and web UI. Use Elasticsearch storage for production. B3 headers propagate trace context and Brave automates this in Spring Boot. Sample at 10% or lower in production. Use tags over annotations for practical searchability. Choose between Zipkin and Jaeger based on your stack, or go with OpenTelemetry and defer the backend decision entirely. Tomorrow on day 14 we continue building out the observability stack. See you then.